Okay, so question 13, we've got a lift with a box in it and a boy sitting on the box. And we need to, first of all, look at the tension of the cable. So there's a cable up the top. I'm going to call it tension T. And at first, we're going to just look at this as one big blob together, and the tension's pulling all of that up. So we're going to have the weight for all of this going down. So if I add these things up, comes to a total mass of 1,115, and then we need to times that by gravity to get the weight. And then it tells us it's going upwards but decelerating. So if you like, if it's decelerating but going upwards, that is -2 upwards, or I'm going to call that an acceleration of 2 downwards. So -2 upwards or 2 downwards. Okay, now I'm just going to do a resultant force equals MA business on this. So forces going down are 115 G. Take away the force going up is mass times acceleration is down of 2. So these should both be the same sign as each other because they're both going in the same direction. Okay, rearranging plus T over there, move that over. That's a calculator jobby. Comes to 8697 newtons. Okay, let's move on to part B. Okay, so for part B, we're looking at the magnitude of the force exerted on the box by the boy. So because every force has an equal and opposite reaction, the magnitude of the force of the box by the boy is the same as on the boy by the box. And it's easier to work that out because the box has the lift going on with it, whereas the boy only has the box going on. So we're going to look at the force exerted on the boy by the box, and then it'll be equal and opposite. So this is my boy, and then the box would be here. And we're going to just look at the forces happening on the boy. So the boy has his own weight, which is 45 G. And then he also has a reaction force from the box. And we know that he is moving, well, decelerating up at 2 meters per second, which is the same as acceleration down of 2. And then we're going to do F equals MA again. So these need to have the same sign. So I've got 45G minus R equals MA. So that's my force equals mass times acceleration. Just doing a little bit of rearranging. And let's put that in the calculator. It's 351 newtons. Okay, now we're going to do the same thing just for the box. We're just going to do a force diagram of the box. So the box weighs 20 kilograms. So just looking at the box, we've got its own weight. We've also got a force that's happening from the lift acting on the box. I'm going to call that R2 because we've already had an R. And then from the previous part of the question, we said that the force of the boy on the box was 351. and it is decelerating up at 2 or accelerating down at 2. And we're going to do F equals ma again. So forces going down, we're going to do down as positive. This, and this all need to have the same sign. That needs to have the opposite sign. So forces going down are 20g, 351, and then R2 is going the other way, and that's equal to ma, which would be 20 times 2. So moving that over, moving that back, we've got 20g plus 351 minus 40 equals R2. And let's put that in the calculator. So R2 is 507 newtons.